about to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out. Die with my own doubts. Be free with me. Let's go, let's be free with Not looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out. Die with my own doubts. Be free.
Morning, everyone. It's Jim here at Tutor2. Welcome to our latest AQA A-Level Psychology revision session. And I said good morning. It's unusual for us to be having a morning session, but for many of us, it's half term, so we thought we'd put a morning session into the diary away from our usual 5:30 slot. But I'm pleased to say that our two regular presenters are with us. It's Lara and Anne. Sorry, I was about to say good afternoon. Good morning.
Morning, everyone.
Can you believe we're up this early? I can't believe there'll be nobody joining us, will there? No, there's no A-level students get up at this early time. Actually, no. Looking at the live screen, there are loads of students joining us live.
Yeah, I think there are quite a few tapping it, and plus we've always got that playback as well. So
good point, Lara. Yeah, so we're gonna dive into this. It's actually our second session on data handling, part of research methods. So we did a really great session last week. So don't forget you can catch up on that on replay if you get a chance to later on. And well, I suppose it's more of the same, isn't it? We're just exploring more features of the key data handling topics with Lara and Anne. And as always, use the live chat to answer the activities so you can have a go. And there'll be some supplementary questions, as always, from Anne and Lara as we go. I think we're good to go, are we? What do you think? Should we make a start?
Yeah, let's go for it.
Okay.
Okay, guys, so just a reminder, as we said last week, so research methods is primarily assessed in paper 2. It is worth double the amount of marks. So usually a section is worth 24. This is 48 marks. And just to be really clear for all of you, the advanced information, nothing has been taken out of research methods. So all of research methods is being assessed in the A-level this year. 10% of research methods is dedicated towards mathematical skills, which is at the kind of higher level maths GCSE kind of level. Although research methods is assessed primarily in paper 2 at the kind of 48 mark section at the end, it is assessed across all papers and topics. So you can expect to see research methods questions in paper 1 in all the topics, paper 2 in the other topics, and in paper 3 as well. And really, we can't emphasize this enough, it really is the foundation of psychology. So if you're going to be kind of really strong at a certain topic, make sure it's research methods. So let's have a quick reminder of the specifications specifically for data handling. So we went through quite a bit of this last week, but we're going to go through accentuate the bits that we didn't go through so much. So we're going to kind of have questions on pretty much most of this today. We're actually going to kickstart off with just having a little reminder of our measures of dispersion. So our two measures of dispersion that are quoted in the specification here is the range and standard deviation. So if we have a look at the next slide, and we'll have a little reminder of what the range and standard deviation actually is. So here they are, like I said, measures of dispersion. So we're looking at how spread the scores are from the mean. And as it says here, and a reminder for you all, and I'm sure this will ease you all slightly, you do not need to work out the standard deviation for AQA A-level psychology. You do, however, need to be able to interpret standard deviation scores. Now, the score you will have to be able to calculate is the range, okay? And that is the highest score minus the lowest score, for those of you that need a reminder of how to calculate that. So just a bit of a reminder of those measures of dispersion before we start today, and we are going to kickstart off with our 10-second game, and really encourage you all to kind of write down your responses in the chat, as Jim said at the start. So you're going to have 10 seconds to answer the question on the screen. Let's have a look at the first one. So what type of data is the end result of a content analysis?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Okay, we've got some varied answers so far. Naomi, well done for getting in there first. So some of us, well, most of us are saying quantitative, but there might be a little bit of confusion over this. So can anybody elaborate on that? So it is quantitative, which is numerical data, so numbers. But why is it quantitative? What are we doing here? Can anybody elaborate on that? What is content analysis? What are we doing with the data? Mercy, well done. We are doing coding. You're quite right. Yeah, we're coding. What does the data start off to be? Can anybody give me an example of a type of data or a stimulus that we may carry out content analysis on? Naomi, well done. So we are tallying up. So we're doing a frequency, a count up, just a tally, as you said, based on what appears in the codes or the categories that we've chosen. Yeah, Fatima, well done. Qualitative data into quantitative data. So who can give me an example of a qualitative piece of data? What may be a qualitative piece of data we may? Yeah, Tom, really good. So you could do it on a speech, a presentation, Emma, opinions. Yeah. We could do it on an article, an interview transcript, for example. Yeah, and we do use codes, okay? And usually the researcher familiarizes themselves with the qualitative stimulus, with the text, let's say, for example, and they come up with the categories or codes, and then they read through it again and then they would apply the qualitative data to those codes and tally up when they occur, therefore turning it into numbers into quantitative format. Well done, really good response there. Let's go to the second question then. So give a strength of producing qualitative data.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Yeah, good. We're getting quite a few responses coming in. Naomi, you're in there first as well. Again, rich and in-depth analysis. Well done. Toby, you're saying rich in detail. Saffron, well done again. Halima, more in-depth, definitely. More in-depth than what? We're saying quantitative. Yeah, more depth of answers. Emma, we're saying it's a bit more holistic. Data is varied, specific. Fatima, actually, this is really interesting. So able to understand reasoning and justify behavior, because I guess people are able to elaborate on responses and give their opinion a bit more. Yeah, Tom, really good. You get more details that you might have missed if you got quantitative data, and you can definitely ask further questions for more details. Yeah, really good responses coming in there. So yeah, quite right. It's rich and detailed. It also provides, and I think quite a few of you were kind of pointing to this, greater insight into a particular behaviour as well. So we've got a couple of strengths there for you. Perfect. Let's move on to the last 10-second countdown question. So we have identify a difference between ordinal and interval data.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Okay, so what have we got? Hey, it's Di. You said ordinal is categories. Yeah, you're not wrong there. How is that different from interval, though? Naomi, interval, an example would be time. Ordinal, an example would be scales. So what is actually the difference there? Remember this question, the key word here is a difference between them, as opposed to outline them separately or give an example separately. Toby, you're saying ordinal can be ordered. Interval uses specific units. You're close, kind of there. That's really good. Ordinal is ranked. Yeah. Okay, Saffron, what have we got? Ordinal data shows the order of a set of data, whereas interval data shows the difference between, for example, between 3 and 4 seconds is 1 second. Yeah, we're a bit closer there. That's really good, that example of interval. Yeah, okay. I'm gonna give you a easy way to remember the difference between these two. Now I want you to see ordinal as both ranked data. Okay, so they're both ranked data. That's where they're similar. The big difference between the two is that one is subjective, one is objective. So a lot of you kind of were pertaining to this in your answers. So our ordinal data is actually subjective ranking. So like a Likert scale, 1 to 5. That you could arguably say is subjective, because maybe a 3 to someone might mean something different to someone else who rates it as a 3. Interval is a lot more objective. So for example, I think someone did actually put temperature down. I can't see who it was now, but someone did say temperature, and quite right. So if we look at temperature, if we look at the difference between, let's say, 1 and 2 Celsius, that difference is the same between 2 and 3 Celsius. So it's equal measurements. It's a lot more objective Whereas a Likert scale, the difference between 1 and 2 on a Likert scale, and maybe the difference between, I don't know, 4 and 5, might not be equal to some people. It's quite a subjective kind of rating apparatus, if you like, a scale. So that's a really nice way to remember the difference there between ordinal and interval. So ordinal, Likert scale as an example, and interval, something like temperature. Great, really, really good responses there. Going to pass you over to Anne now, and you're going to play the 3, 2, 1 game.
Okay, so in this game, you've got 2 minutes to answer these questions. Don't just put the answer into your box, but don't press send until you've answered all of them. Okay, so you've got 3 questions there. So the 3 measures that should be plotted on a distribution graph, 2 strengths of a correlation analysis, and 1 reason as to why a histogram would be used as opposed to a bar chart. Okay, so off you go, and you've got 2 minutes. I don't know if we've got a timer. Oh, yes, music.
5,
The music stops.
4,
Press the answer.
3, 2, 1. Five, 4, 3, 2, 1.
Okay, let's see what we've got. Histogram is going. Oh, 3 mean median mode. Histogram, no. Yeah, mean median mode shows really are not related. Histogram show measurements of time. Not bad, Daniel. Okay, waiting for some more to come through. Only Daniel and Halimar had a go there. Oh, no, I've got another one. Okay, we're getting to the first question. Is that significant? You can. Well, yeah, I suppose that would work. Yes. Anybody else before we start to look at answers? Just press what you've got, even if you've not finished. It doesn't matter. They're quite challenging questions, those. Okay, we'll go to the next slide. Anyway. Oh, I've got another one. Yep. Yes, that's the right answer to the third question. Okay, lots of people getting the 3s. Yeah. Okay. Right. So yes, if you were plotting a distribution graph, yes, you would plot. You should plot the mean, the mode, and the median. If the data was normally distributed, where should those points be? So if the distribution was normally distributed, where would you expect the mean, the mode, the mean, the mode, and the median to be? Yeah, we've got some good answers on 2. I think a lot of people have got as far as 2. So where would you expect the mean, the mode, and the median to be on a normal distribution? Yeah, well done, Tom. In the centre of the curve, which you'd expect to be symmetrical, and the mean, the mode, and the median would be approximately the same. They would be very close together. But if a distribution was positively skewed, which of these measures of central tendency would be the highest? So if you had a positively skewed distribution, which of these would be the highest? The mean, the mode, or the median? Let's see any other answers here. Getting everything here. It should be the mean. It would be the mean score. The mean would be the highest. That would be the most pulled across, because that one's the most sensitive, where you've got extreme scores at the high end there. So it would be the mean. Okay, thank you. Okay, so we go to question 2. Okay, so quite a few of you got some of these. So strength of correlation is, it can be used when we cannot manipulate variables. Somebody put with socially sensitive research, and that would make sense, because research in that area, very often you can't manipulate the variables, so you have to stick with correlational research. So where you can't manipulate variables, either for ethical reasons or for practical reasons. And the second one, and again, I think some people kind of got this, they can identify trends for future controlled research. And I think somebody said, well, if you're not finding any correlation at all, then it suggests that there is no cause and effect, so there would be no point in carrying out any further investigations. And that also kind of points out the limitation of correlational research is that it cannot assess cause and effect. It can only tell you that two variables are related. So if you do want to go on and test for that, then you need to then set up an experiment and manipulate something. But there are some areas where you cannot do that. Okay, so quite a few of you got that. Looking at question 3, this was a really tricky one. I think a couple of people got there. Might have been that you didn't have enough time. But one reason as to why a histogram would be used as opposed to a bar chart is where you've got data that's on a continuous scale. So somebody gave times as an example, and yeah, time is a measurement where you've got a continuous scale at the bottom. Rather than with a bar chart, you've got discrete variables or separate variables there. And so that's why you never join the bars up on a bar chart, because it doesn't make any sense, because the pattern shown depends on how you choose to arrange those, those variables on the bottom axis. Whereas with a histogram, it does make sense to look at the pattern, because you've got a continuous scale of measurements, and say time is an example, temperature would be an example. Okay, so I'm going to hand back to Laura then, unless anybody's got any questions. We'll have to go for calculation.
Guys, we are doing the calculation countdown now. So just before we start, if you don't have one in front of you, but I'm sure you all do because you've got one on your phone, make sure you have a calculator to hand, because you are going to be asked to calculate the mean, mode, that should be median, and range for the following data set. Okay, so you will need a calculator out in front of you. So hopefully you've all got that, and we're going to start the calculation countdown now. think we might put that clock around one more time, maybe, to allow you a bit more time, because there's quite a few to work out there. Okay, really good. We've got some really good answers coming through. I think we might have a slight typo on the mean here on this slide, but let's have a look at our answers. So we should have, the mean actually should be 5.8, and I think quite a few of you got that correct. I think the answer came out as the total 52. Divide that by 9 is 5.77. So we'll round that up. That's 5.8, so well done. The mode is the most common figures in that data set, and we should have 3 and 9. Quite a lot of us have said, yeah, so it's both. So some of you've either put 9 or 3, some of you put both, but it is 3 and 9. They're both common figures there. And the median is the middle score with them ordered, and that is 5. Again, quite a lot of you have got that correct. Really good. And the range is the highest, subtract the lowest figure, which actually equates to 9. So I think quite a lot of you, looking at all of your answers there, have got that correct. Just a reminder of how to calculate, just go through that. The mean is adding them all up, dividing by how many there are. The mode is the most common figure. Median is all of the figures ordered from lowest to highest, and the middle score. And the range is the highest and the lowest subtracted from each other. So well done, guys. I think most of you have got that correct. Let's go over to the next calculation. Well, this isn't really a calculation, but I do believe AQA have actually asked this question before, and they've actually said it as it is on the screen. Explain what is meant by P, that sign, and 0.05. So in written format, if you like, guys, I want you to write out what exactly that means in the quotation marks. Okay, Toby, well done. You were the first one to get that completely correct. What we really want here is what P means. So P means probability. A lot of you missed out the sign. It's really important to understand what these symbols mean. This is equal to or less than. If we take that straight line away underneath the sign, that would just be less than. But because it has the straight line underneath, that's equal to or less than. And 0.05 can also be denoted as 5%. So well done, those of you that have got that correct. I can obviously see here that a lot of you understand the 5% level, in the sense that, so a lot of you have said, you know, we can be 95% sure and 5% unsure. In other words, you know, there's a 5% chance the results could be due to something other than the IV. So the understanding's there, which is really great, guys. But this particular question is really asking you to explain what that kind of equation symbol means. So what does P mean? What does the symbol then mean? And what does 0.05 mean? So you would have to explain it in that format. So Toby, really well done there for getting that correct. The first person to get that correct there. Well done. The next one then, convert this to a 3 significant figures. We've got 5.2682. Excellent answers. So Dean, firstly, well done for getting that correct first. We've got a few others here. Love, laugh, chatter, well done as well for getting that right. Daniel, yeah, perfect. Really good. So just to be clear, the 8 rounds the 6 up to 7, hence why it's 5.27, which is what pretty much all of you have got. So really good to know that you can do that. I'm now going to pass you over to Anne, who's going to do a true and false game with you.
Okay, so true or false, so just put true or false or T or F in the box. So 22.4% into a fraction is 0.0224. True or false? Wait to see if a few more answers come through. Yep, people are coming through as false. Okay, does anybody know what it is as a fraction? Can anybody work it out for me? How would you represent that as a fraction? Because it is false. That's still not a fraction, Fatima. A fraction, it kind of is. Can anybody do it as an actual fraction though, rather than as a 0.224? Nearly, Halimar. You needed another. Oh, you're nearly there. You need another 0. And it should be 22.4. You can't really do that, can you? It should be 224 over 1,000, which Toby is absolutely right. Is 28 over 125, because there's a common denominator of 8. So well done, Toby, because that's quite a challenging one. Yeah, I had to really think about that to work it out myself. Okay, so 5 males and 15 females. The ratio of males to females is 1.3. Is this true or false? Yes. Yes, it is. And again, that's something that you might get asked. And remember, you need to take it down to like the lowest common denominator. So it's 1 to 3, because both are divisible by 5. So well done. Okay, if we go to the next one. If there are 100 raffle tickets in a bowl, the probability of pulling out number 88 is 0.01. Is that true or false? Waiting to see it for a few more answers. Mixed answers here. Okay, we had mostly trues, and now we've got a little flurry of falses there. Okay, so we have a look at the answer. It is true, because you've got a 1 in 100 Well, we're presuming they do. Yeah, we're presuming they do. We've got a 1 in 100 chance. If there's 100 in there and only 188, you've got a 1 in 100 chance of pulling out 88. Okay, so that's correct. Okay, if we have the next one there. So a type 1 error is a false positive where you reject the research hypothesis when it is true. True or false? Nobody's going true here. Okay, let's see the answer. Because this one got me. Okay, who read the whole statement? Can anybody tell me why that is false? Yeah, wait. Why is it false? Tell me what's false about it. And why did so many of us get fooled? Yeah, because you don't read long far enough. Because the first part is true. Okay, so we read a type 1 error is a false positive, and then you stop reading. But the second bit is actually wrong. Okay, so I can see why people put true. So a type 1 error is a false positive, but this means accepting the research hypothesis when it's false. Okay, so it's a lesson to us all to read through all of the information carefully before we make a decision. Okay, because I nearly fell into that trap as well. Okay, so let's have a look at the next one. Okay, so you'd be more likely to make a type 2 error if you chose to use the 0.01 level of significance. This is because it's too strict, meaning you are more likely to reject the research hypothesis when it is true. So is that statement true or false? And hopefully everybody's reading carefully now. Okay, so we're all unanimous on this one. Let's have a check of the answer then. It is true. You are right, because the type 2 error is a false negative, and that does mean rejecting the research hypothesis when it's true, and that is more likely to happen when you use a significance level that is too strict. Okay, because 0.01 is much stricter than the typical level we use in psychology is 0.05, and that's because it kind of achieves a balance between making either a type 2 error or a type 1 error. But if you make it stricter than that, then you're more likely to make a type 2 error. Okay, so well done, you didn't get fooled by that one. Okay, so if we go to the next bit, then we're just going to have a little look at scatter graphs. Because I think of all this, when students are asked to plot a scatter graph, you get all sorts of really weird and wonderful graphs that do not look like this, that often have two sets of data plotted on them. And you just think, oh no. Scatter graphs are used to present correlations. To show when there's a relationship between two things. And so always when you're asking to plot a scatter graph, it will tell you or to plot an appropriate graph is often the question, and you have to work out that it's a scatter graph. It will be a study where it's looking for a relationship between two things. And so each participant will have two sets of data or two scores. But it won't be an experiment. It will be looking for a relationship. And so on your scattergram, there should be as many dots or as many crosses as there are participants. And the dot or the cross should be put at the intersection of their scores. Okay, so in this study, it was to see whether there was a relationship, like in the title, between performance on an exam and the number of hours slept, presumably the night before the exam. And so from that, if you look at the participant, the second participant, the one that had 2 hours sleep and only scored 20%, that's quite easy to see on the intersection. And then you've got one of them that's had 8 hours sleep and 80 hours sleep. It doesn't matter, actually. I would tend to put a cross if I was plotting it, but I think when it's done on Excel, it puts a little circle, but it doesn't matter. The crucial thing is to make sure that your dots or your crosses are in the right place, because obviously you're getting marks for plotting it correctly. And then you might be asked to interpret what the graph is, what the scattergram is showing, or the scatter graph. And this one is showing a positive correlation. It's a relatively strong positive correlation, that as well, because there's no kind of major outliers there. So it's showing that sleep and exam performance are related. Yeah, it depends what you're doing. Yeah, but you know, sometimes it's either a graph to plot or that you'll want to interpret. But as I say, when students are asked to plot them, we do get some weird and wonderful things. Okay, so we've got one here. So this is already drawn and this is to interpret. So it's a scatter graph to show the relationship between stress scores and the number of days absent from work. So an employer wanted to find out why some staff have more absences than others. To do this, they gave all of the staff a survey to fill in about life events, and that calculated a score. So the greater the score, the more stressful life events somebody had. And the scores were then correlated with the number of days each person had been absent from work. Okay, so if you saw that graph then, if you just click to the next slide, what do you spot in the graph? So what's that graph telling us? Yeah, you can see the 6 participants. Yes, that's true, because there's 6 plots. And it's showing a positive correlation, isn't it, between somebody's stress score and the number of days off sick. Yeah, it is positive correlation, but like Toby's done, really, you need to say between what in your interpretation. Okay, so if we just click, so what information then from the scenario do you need to kind of pick out to help you to answer that question? In fact, some of you had done that. Yeah, we do. This is for AQA Ironman, yes. So it might be slightly different for your board. Sorry, I've not missed your question, but a lot of the things will be the same between boards. Okay, so things that we need to pick out. Well, some of you had picked out, that's in the actual graph. You'd need to pick out the direction of the dots, which people did. But the key information in here was things like it was an employer that was doing it. They were what their purpose was. They wanted to find out why staff have more absences, that they'd used a survey, and then they've got life event score and the number of days absent. Yes, and that was what you needed to include. When you were saying there was correlation, you needed to be explaining what the correlation was between. And so if we just click to the next one, that's why rather than kind of jumping in straight away and answering the question, decode the question. So go through, underline any kind of key points there. Because you wouldn't just get that question, you would get some follow-up questions or some other questions as well. And this information would be really important. I think students, when they're faced with scenarios in research methods questions, often just jump straight in and start answering them without actually decoding the question and underlining all the important things that they might be asked about, and then not contextualizing the answer. So saying something like there's a positive, it's showing a positive correlation, but not saying between what. I think we talked about this last week as well, if you were here, that often the questions will say in this study, and it's really, really important that you contextualize your answer. Otherwise, you're restricting yourself from getting all of the marks. And on research methods questions, if you're missing one mark and then another mark and then another mark, and that, for things that you actually knew, then those marks will very quickly add up. Okay, so I'm going to pass you back to Laura now. She's going to go again, look at some exam questions.
Okay, well done. So this is the last exam question for the session today. So if we just have a read through the STEM here together. So a psychologist had quite a few friends who enjoyed taking part in dangerous activities such as bull running and parachute jumping. The psychologist was interested in what motivated them to take part in such activities and how they felt while taking part. He decided to use unstructured interviews with 5 friends to find out more. The interviews were recorded and then analysed. Explain how the psychologist could have carried out a thematic analysis in this investigation using the recordings. Now, this is only worth 2 marks, but there's quite a lot going on there. So what I really want to know from you guys is, what is it you should be spotting in this question? What are kind of the key aspects of this question? And really, in kind of reply to that as well, what is it that you think students really miss out here or don't take notice of in the question? So what is it we should be spotting here in the question? What are the key things to make sure that we take note of? Okay, some good answers coming through. So we're noticing various things. So the fact that they use unstructured interviews, they were analysed, and thematic analysis, good. Yeah, Ebony, that's key, that last bit. Well done. Explain how they could have used thematic analysis. So we can see here, guys, really good responses, but the key parts here, it's quite a hard one. The questions at the end, as you can see, it's asking you explain how the psychologist could have. The explaining how is kind of the procedure more, if you like, how to do a thematic analysis. And I guess the key aspect here with regards to the amount of information they've given you is in this investigation using the recordings. So what students often do here, and some of you may have noticed this, is students tend to talk about thematic analysis, but they don't tend to make it STEM specific. It is clearly saying here in this investigation. So if we go forward and just have a look at some of the kind of planned format of the answer on the next slide. So we've got here, just to be clear, we've got 2 types of kind of qualitative analysis. We've got content and thematic. This question is asking specifically on thematic. Now, you do need to know the difference between these 2. Does anybody know the difference between content and thematic? Can you explain what that difference is to me? What's the difference between content and thematic analysis? Any ideas? They're both analysing qualitative data. Yeah, Naomi, first in there, really good. So content is quantitative in terms of that it converts qualitative to quantitative, well done. And thematic is qualitative, so it stays qualitative. Yeah, really good. And hey, it's a diet. Yeah, you got that right as well. So yeah, just to be really crystal clear with you all, thematic analysis is still analysing qualitative data, but instead of really reducing it to numerical format, we're reducing it, but we're just giving a qualitative summary under each category or code. So we're not reducing it to numbers. So we're keeping that kind of subjectiveness of the person, that rich detail still, and not reducing it all the way down to numbers like content does. So if we have a look at kind of a bit of a sample response here, we've got, for a thematic analysis, the researcher would need to read through the transcript of the interviews because, you know, being STEM specific, they did unstructured interviews, as you guys spotted. And then they'd use a coding system to identify themes related to what people are saying about why they take part in dangerous sports. So again, we're not reducing that to numbers. We're not counting or tallying under the codes. We are looking for themes and then codes underneath those themes, and we are basically reducing the amount of qualitative data. But the key thing here is that we are keeping the qualitative data there. We're not reducing it down. Okay, really good answers, guys, today in the session. I do believe that is the last of the activities to go through today. So some really, really good responses coming through there. So that is our last one on data handling. Not forever, I'm sure we'll do some more. But next week, as Jim said last week, we are doing memory next week, and that will just be the advanced information memory, and that will be kind of an overview of all the advanced information for memory. And next week will be normal time, so it'll be 5:30 again on the Tuesday.
5:30, back to our normal time after half term. And as Laura and Anne said earlier, for the next few sessions, we're just going to focus on giving you an opportunity to recap and revise the advanced information bullets and topics that AQA issued a couple of weeks ago, wasn't it? So that'd be a good way just to sort of start to crack on with those. Fantastic. Many thanks. Well done to everyone who's got involved in the live chat. Lots and lots of students joining us. I knew you'd turn up at 9:30 on a Tuesday morning, and Lara and Anne did as well. So that's much appreciated, all the effort you've put in today. If you're watching on replay or catch up, of course, much appreciated too. Give us a thumbs up if you found the session useful. Don't forget, if you go to tutor2u.net/live, you can go and catch up and replay the 30, 40, maybe even 50 sessions we've done now over the last 14 months or so, covering just about everything on the AQA level specification. So a great opportunity if you just want to mix your revision up just to work through some of those sessions as well. And also you can download all the PowerPoints as well. So that might be useful too. But we're back this time next week. Not this time. This same day next week, 5:30, and it's memory. Don't forget, memory next week. And we'll see you later.
Bye, everyone.
Bye.
See ya.
Bye.